Right. So we'll set this. Oops. Okay. So let me explain this one a little bit. Oh yeah, before I do that, actually, let me give you these. Oh, looking mess. You can do it yourself. These are your logbooks for tomorrow. Logbooks.
So you should write something.
You should write everything in that. Fine. 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 Not yet, no, do it later, do it later. Later. Let me just talk about the book a little bit. So you notice that in the book there are 3 experiments. Yeah? Now the way it works is you have to write in the book for 3 of the experiments, but the 4th one you must type. Type. Yeah. And also one of these 3 you must type.
So choose one to type.
Choose one, correct, but I'm telling you which one to choose. So the one you should choose, it's the best one to choose for typing, is the electricity one. Or if you want, you could choose Newton's one, which I haven't done yet. No, sorry. I didn't say that. If you want, you can choose the electricity one or the pendulum. The pendulum. Do not choose to type this one. There's not enough in it to type a report. Okay. So lab number 1. Oh no, don't write it there. No, it doesn't matter. This you have to give this back to me. Yeah. So listen. Lab 1 is actually this one I'm going to do now. Lab 2 is the pendulum, I think. Lab 3 is the electricity one. And lab 4, which is not here, is the Newton one in the box still. Okay. Now, if you just go, please, first page is just your information. And then here is lab 1, for example. Can you see lab 1? Yeah. So, you have the title. Of course, you know what to do there. Harry! Put the phone away. Yeah. You have the title, your short introduction, and then...
How much more introduction?
Oh, just fill up this box.
How many? I can write out a big letter. Yes, very big letter.
Just write normally, please.
One word only.
Write normally.
My bit is the experiment 1. And the name is part of.
No, you need to say what you're trying to do in the experiment, please. So, for example, with the pendulum experiment, what are you trying to calculate? The G. And with the electricity experiment, what are you trying to calculate? The R. Yeah. So you could say, this is this is the pendulum experiment, which is used to calculate the value of G, the acceleration due to gravity, something like that. Oh, don't write it. Yes. Now, the next is the method. So here you have the material you use. So this is a list of the equipment. Okay. So for example, with the electricity, what equipment was there? There was the voltmeter, the ammeter, the battery, the switch, all this stuff. And then here, diagram. This is where you draw the arrangement.
What? Which diagram?
Diagram.
It's like this one?
Yeah.
Or this two?
No, like this. Or like for the electricity one, you draw this. For the pendulum one, you can draw this, you know? Yeah. And then, procedure. This is what you do. So, don't write it as points, write it as a paragraph. Okay, so you would say, first, put the pendulum on a steady, stable table, you know. Then, attach the clamp to the top of the stand. You know, just describe what to do.
Are you put right in past tense? Or it doesn't matter?
I personally am not so picky. The only thing I really care about is,
The points are right.
yeah, I'm not too picky, and the only thing that the moderator cares about in Manchester is he doesn't like when people use points. So he doesn't want points, he wants kind of a paragraph. Is this what you do in chemistry?
Yeah.
And how do you write in chemistry?
The pendulum was placed on the table.
Yeah, so this
was
what's this called? Passive, is it? Yeah. This is fine. This is good actually. So just like chemistry, the pendulum was placed on blah blah blah. Yeah? And then on the next page, now this is the important page, your results. Okay? So here is where you write, you know, L min, L max, and all this, okay? So this is what you can do tomorrow, because later, after the experiment, you can fill out this, okay? But you can't do this part later. So this is the part that you must use tomorrow, the results. Okay. Then on the next page, this is where you make the graph. Yeah, so that's straightforward. Oh, this is just the description of the graph. So like you would say, a graph of current against voltage. The description. Okay? Then on the last part of the lab is the analysis. So this is where you do your calculation. So for example,
use the paragraph or just write on the tab?
you should try and explain your calculation. So for example, when you want the slope, you would say, using 2 points on the line, calculate delta x, delta y, and then you have the slope. And then you can say, for example, the resistance equals 1 over the slope, and then you get the or equals, and so on. There's another part which we haven't done yet, calculating the uncertainty. And that's something I'll do in a later class. So, you might want to leave this bit until after our next physics class, the analysis part. There's a little thing I need to do first before you can fully finish it. And then the conclusion at the end, you know, so, conclusion. So you calculate the G, but there were some errors, you know, this is the true value, this is the value that was got from the experiment, you know, the usual conclusion. You try to, what's really important, the most important thing in the conclusion is really what you think went wrong and what you could do better next time. So for example, maybe you could say, oh, next time the table was a little bit wobbly, so in future a more stable table should be used. You know, something like this. No, but you're writing this down as if like this is brilliant stuff I'm saying. This is not brilliant stuff I'm saying, okay? I'm just giving you ideas. So you must write up 3 of the experiments, but for the 4th experiment you must type it. I left some blank paper at the back for you to record the information for the why does this not have the page numbers on all of them? Oh well.
90.
Yeah, this at the back is just for experiment number 4, so you can have some space for the numbers to record them. Yeah?
Yes.
Which one?
No, I see the number 7.
This one here at the back is for experiment 4. You don't actually need to write experiment 4 in your book, but you do need to write the numbers down so you can type it, because you need to type experiment 4. So you need
2 and 4 experiments you type.
2 experiments you type, and 3 of them you write.
2 is type.
2 is
But you
type.
said experiment 4 is 2.
Experiment 4 is type, and one of these.
Wait.
Yep.
Experiment 4 is type.
Yeah.
And
Okay, let me, I'll make it very clear for you. Okay. The experiment, listen. This experiment I'm about to do, only write. The pendulum experiment, only write. Okay. The electricity experiment, write and type. And then the Newton experiment, I'll do later, only type. So you have 3 you write, 2 you type. Yeah. So the first one, the pendulum, only write. And then the next one, for example, the electricity, that's write and type. Then this one here, this is Snell's law. This one is only write. And then lastly, Newton's experiment, which is in the box, only type. Is that okay? Is it clear? Now listen. What's supposed to happen is you're supposed to do these 4 experiments tomorrow, and then after the experiments I'm supposed to take this book. But I won't tell anyone if you don't tell anyone. So you can take this home and finish it at home. Okay? So that's fine. Also, for the Newton experiment, you need to design the experiment before you do it, and then send it to me in an email. Okay? Now again, you really should do that in class, but you can do it at home and email it to me. Yeah, now the 3 of you know what I'm talking about, because you might even have this still in an email, do you? No? You never? The Newton experiment, you have to design it, and
We just do the experiment.
No. Are you sure? Because I remember Fahad and KJ and all of them did it.
We just do it.
But do you remember you had to make the picture for the Newton experiment and what you need to do?
No.
Are you sure?
After this, we change to intake 2.
So you never actually did it.
Yeah.
That's fine. Okay. So what you need to do, which you need to do tonight. Are you listening? This is you must do tonight before the experiment tomorrow. Is you need to give me the design for Newton's experiment. Now we'll talk about that later in class. Okay. So the design is basically what you must do. So it's the diagram, the equipment, and the procedure. Now this will be much easier for you to write once you see me do it. Then you can write it. And then we will pretend you designed it yourself. Yeah. Do you understand what I'm saying? Yeah.
Can you just follow this?
Yeah, but you just need to type it. So basically, if you give me that here, so what you need to do for Newton's experiment is basically type this page up and send it to me. The title, actually you don't need the introduction, the material, the diagram, the procedure. And then this will be part of the final typed report for Newton's experiment. So you will use it again later in the final report.
Does it have to be in the box?
No. Just this is what I'm looking for. But type it up normally. Yeah. Anyway, we'll talk about that a little bit later. So let's have a look at Snell's one. So for Snell's law, oh, okay, you know what it looks like. Anyway, the laser comes in, and then this angle here we measured with the normal. So that's here I. And then what happens? Change. What's the verb? Refract, yeah. So then you have a different angle here, or. Do you remember what Snell's law is? Sine I over sine or equals. No. Or hang on, if you want, great, Amanda, that's sine theta 1 over sine theta 2. It's the same thing. Equals what?
B? No.
Nope.
Something water or.
Yeah. So this.
Water.
N2 over N1.
Yes. This is what I have to say.
Yes, good. So N1 is 1, and N2 you don't know. This is what we want for this experiment.
N1 is the air, right?
Yeah, air. So which is the thing that you're changing? What do you change?
Change the angle.
Which angle?
Refract.
I or?
R.
No.
You change
I?
You change the I. So you can say sine I multiply N1 over N2 equals sine or. So this is like the Y. This is like the X. I kind of wrote this backwards. Sine or equals N1 over N2 sine I. So when you make the graph, here you put sine I, and here you put sine or. Sine I. So what's the slope here of this graph? N1 over N2. Now which do you know, N1 or N2?
N1.
Yeah, you know it should equal 1. So what does N2 equal?
N2 over N.
1 over 2.
It will equal 1 over N.
Yeah, 1 over slope. Yeah. Yeah. Okay. just actually before I go on, not that it's a big thing, but it's just something that jumped into my head. Do you remember earlier I said you should have like L-min, N-max, V-min and V-max and all this stuff? When you're writing this in your notebook tomorrow, instead, actually, can you write it like this, L, and you can write 1 here or something, and L2, and this could be V1 and V2. I just think it's a little bit better than having the, whoa. I don't really want the words, I want a number or something. I just don't want you to write V-min. I think that's kind of ugly. I think it would look nicer if you wrote like V1 or something like this. Or you could write VI and then VII. Something like this. You know what I mean? I don't want words. I don't want min or max. I want a number or a letter. Don't ask me why. It's personal. Okay. The reason, actually, no, seriously, the reason for this is that the physics moderator in Manchester, he said that when the students do the physics labs, he wants to see 2 measurements for each measurement. So, for example, with the electricity one, you remember that it changes a little bit. There's a minimum and a maximum. So I want you to call the minimum V1 and the maximum V2. So these are like the 2 measurements for the first one. It's not a big deal. Instead of saying min and max, just say 1 and 2, or A and B.
So in here it changed to?
Yeah, instead of V max, say V2. Yeah, V1 and 2. It's not a big deal. Or V, A and B. Whatever. Okay, so let's have a look at this one here. So, it's not lined up correctly. There we go. So first make sure the 0 is with the line at the top. It's not great, but it's okay. And then we turn it on. So for 0, you should get nothing. You should just go 0, 0. Nothing happens. So what? Oh, sorry, wrong way. There's 10. And then you can measure the angle down below. Now, there are 2 measurements. So there's I1 and I2. So if I look here, I1 and I2, that's like the smallest and the biggest I. So if I look here, that's like I1 could be maybe 9 degrees and I2 could be 11 degrees. It's about 10 degrees. But I don't know if it's perfectly 10. I don't think it's perfectly 10. So I1 would be 9 and I2 would be 11. Then when you look down here, it moves a little bit. So what do you think R1 is?
About 5.
Yeah, maybe R2 is like 6 or something. You have 2 values here. Oops. Yeah, something like 5 and 6. So what value do you use on your graph? 5.5. Yeah? Is that okay? Get the idea? And then the increases to 20, 30, 40, 50, 60, 70, 80, and so on. Also, for this experiment, you should do it backwards as well, from the water to the air. 0, 10, 20, 30, 40, 50, 60. However, when you do it from the water to the air, you will reach the critical angle. Do you remember the critical angle? So, the critical angle is when this laser comes back into the water. So, here it is here, 0, and then around about 45, now the laser comes back into the water. So the critical angle, you can calculate it using N1 and N2 as well. Okay. So it's okay, isn't it? It's very, very simple equipment to use. Okay, the last one to look at is newtons now. Oh yeah, sorry, let me just show you the table really quick for this. Okay, so what do you think we need in the table? What could be our first one? I1. And the unit? What's the unit?
Degree.
Degrees. And then next, I2. And the unit? Degrees. And then I. How do you get I?
I1 plus I2 divided by 2.
Yeah. And the unit? Degrees. Okay, and then next will be or1 degree, or2 degree, and then or degree. And then finally, you'd have sine I, and then here, sine or. And on our graph, what do we put here? Sine I, and here, sine or. I keep forgetting. Please don't forget this, because I keep forgetting it. The error, I keep forgetting. I should write in here delta I and here delta or. I keep forgetting that. This is the error.
Delta I has the degrees of the...
Yeah. Please don't forget that, because I keep forgetting it. And did I forget it in the last one? I did, of course. So delta V and delta I.
Delta I is after the
Average.
R.
Yeah.
But the R...
I know, that's me being messy. Yeah.
So the R is also after.
Yeah. Okay. Alright, Newton time? Did I forget it in the last one as well? No, terrible. So after this delta V and after this delta I. Okay, Newton time. My toy car. Yes. Now, right. Yeah. So actually, let me draw the setup first. No, I won't. That'd be too much help. So, for this experiment, you're supposed to design it. So, I don't want to draw the diagram, because you're supposed to draw it yourself and figure it out yourself. But I'm going to show you what to do, so then this will help you make the diagram and the procedure and so on, okay? So we have our trolley here, we have our clamp here, and then we enter. No. Come back. Yes, that's great. Okay. That's okay. Now, it's okay. Somebody got rid of my string. So now I need to get the first string. Where's my scissors? Aha. So there's, make a little loop here. It's probably too big. And there's a little pin here that you can put it on. Oh man, that please. I'm not so boring, am I? Okay, and then we have some weights here, but we don't use the big weight, so we could use the small weights here. I know, it's so boring. I know, I'm so sorry. But you get to play with it tomorrow. Okay. I'll just hang this here for a moment. Now, No, we'll do it great. Actually, you know what? I will draw. I said I wouldn't, but I'm just too kind. Okay, so what's happening here? You have your trolley. And you have your weights here. So here the force is equal to the weight, which equals small m g. And here we'll call this one big M. And what will happen? This will accelerate. What's Newton's second law? F equals mass, multiply acceleration. So which are you changing here? What are you changing in this experiment? Well, what we're going to change is the F's here. We'll change this. And then we'll get different A's. F equals the weight. Mass multiply acceleration. Yes. Now, I can rearrange this to A equals 1 over the mass times F. So what does the slope here equal? What's the slope here?
1 over mass.
1 over the mass. Now, which mass is it? Is it M or M or M plus M?
Small m.
You think this one?
M plus m.
It's this one. So please be careful. This mass is the total. And it must be constant.
So the mass is what
It's the mass of everything. Everything that's moving. Yeah. So this gives us a small problem. How can I change the mass here without changing the total mass? Well, what we do, I think some of you know or remember this. If we put all the masses we want to use from the beginning on the trolley, then it means when I want a different mass here, I just take it from the trolley and put at the end. Has the total mass changed? No. So this is the trick to keeping the total mass the same, but changing the force here. So you need a little bit of glue tack to help stick these on because they'll fall.
But you have to weigh the blue tack.
Huh? Do we have to weigh the glue tack? No, that's okay. That is okay.
The mass of the trolley is just goes.
No, we'll get to that in a moment, okay?
Let's change the weight.
Yeah, so we can change the weight at the end by just moving one of these from here to the end. Do you understand? Yeah? Now, we have to do this 8 times. So my advice is you start with 50 grams, then 100, 150, 200, and all the way up to 400 grams.
And we have to keep total mass the same.
Yeah, so you're only allowed to move from here to here. So make sure at the start you have the right weight here. Okay. Now, the other thing, a bit like the pendulum. You remember in the pendulum you have to do it twice, and you have a T1 and a T2, and then you add them and divide by 2. The same story here. You have to do each run twice, and then you use the average of the 2. This makes it more accurate. Okay. Right, so you have to do each one twice. Now, how can you measure the acceleration? Well, this is how we measure the acceleration. Here. So, please be careful. Look, I have this on the ground on purpose. I know that when the trolley gets here, the weight hits the ground. So I must have my light gates a little before the trolley is here. So for example, maybe like here, yes, or put the ruler like here. Okay, so yeah, that's something like that. Okay. Right, so let me just move that out of the way. So I don't know, you two haven't seen this before, but if you look, you hit start, okay, and then it shows the speed of what passes through it. You hit start to reset. So again, this needs a bit of blue tack, and you want it like 30 centimeters apart or something. So we'll put one here, and then we'll put the other one here. So this is 30 centimeters apart from ends. Now, of course, the problem is the trolley will not fit through this. So our idea is we stick a little card on the side of the trolley. And we want this card to break the light gate for us. We put it in the middle. There. Start. Start. Okay.
But the string isn't on the thing.
Oh, that's going to be a problem. Thank you.
What do you call that?
Pulley.
Pulley.
Okay. 0, 0. Alright. Are you watching? Yeah? So, in fact, what's happening is this is the U, this is the V, and this here, the S. So, if you know U, V, and S, can you know A? Yeah. So, what you do this twice. You use the U, the V, and the S to calculate A. Then you do it again, use the U, the V, and the S to calculate A2, and then you average A1 plus A2 over 2. And of course you have the uncertainty as well. So delta A would be A2 minus A1 over 2. Okay. So let's try it. Now, oh yeah, please note, put your hand here so it doesn't fly off the table and break it. Ready? I don't know about this. Alright. So now we have our U and our V. Okay? Yeah.
The U is not 0.
No, it shouldn't be because it started, I mean, it should be nearly 0, but it started moving before the light gate. So, that's okay. So we have a U1, and what's the unit? Meters per second. And we also have a V1, and we also have an S1. Can we use this to get A1? Yes. Then we do it again. U2, V2, S2, and we can use this to get A2, yes? Yes?
Yes.
Now, then we have A. How do we get this A? That would be A1 plus A2 over 2. Yeah? What's the delta A? The uncertainty. A2 minus A1 over 2. Okay, so next then, what's the F? What's the F here? Yeah? What's the F? That's G. Because remember, the force that's pulling it is the weight. Yeah? Yeah? Now, when you calculate the F here, you know the M because the M is on this. So the M is on this. And you know what the G is. It's 9.81. So you can know what the F is, so that's no problem. So we know this, and now we know this. So we can make our graph. This will be F, this will be A, and then this slope here will be 1 over the total mass. So you can prove Newton's law if you can prove that the mass you get in the graph is the total mass. So how do you calculate the total mass? Well, that's easy. It will be 200 grams plus 200 grams plus 50 grams plus 200 grams plus this mass. How do we get this mass? We use this. It says the mass on it. You can measure it. Like this. Okay, so we can get the mass of the trolley. So we can calculate the total mass. This is called a spring balance. Huh? Spring. S-P-R-I-N-G. Spring. You see the spring inside?
1 kg.
Maximum 1 kg. Balance. Yeah. Yeah. Now, what time do you finish today at?
5.
Okay. Are you free at like 1 o'clock? Because I want you to come to the office because I want to give you some papers about the 4 experiments that you can read tonight. Okay, come by the office at 1 so I can give you these papers, okay? Right. Now please, there are 2 main safety issues for tomorrow. The first safety issue is, wait, listen, please, just 2 safety issues. These are the safest experiments I could imagine. So they shouldn't hurt you, but just in case, please do not look into the laser, okay? So don't take the laser and go, okay? Please don't do that, you will cause problems. Please don't investigate this, okay? And secondly, this trolley moves pretty fast, okay? So please, don't have your fingers on the table and you're on the phone and then go over it, okay? Please don't put your head down here so, you're looking up and the weight comes to your face, alright? With the battery, okay? Don't do anything stupid with the battery, like eat the battery or whatever, okay? So, this is not like chemistry. It's much safer, okay? But still, I think the thing you must be careful about the most is this trolley moves pretty fast, so just be careful. And the laser, please don't look at the laser. Please don't look at the laser, okay? It probably won't make you blind, but it might hurt your eye, okay? So just don't look at the laser. I think that's really it. So I'll give you the papers at lunchtime, and you'll do this tomorrow, okay? And we'll talk about writing the report in the next physics class. But for tomorrow, just record the results, the data. This is the most important thing. Okay. Oh, and be careful with this one because this is the most expensive one. The trolley and the weights are like €100. Yeah. So please, don't break this one. It's the most expensive one. Thank you.
So what is trolley?
The trolley is like €25. Oh, trolley. Oh, Trolley. Yeah. No, I'm going to but I'm going to give you some papers later that have all the names on it. So these are called light gates or photo gates. I'll give them to you. Yeah, I'll give you the papers later.
Can I sign the paper and into the...
No. You must handwrite it.
I should draw the picture?
Yes. Do you like to draw pictures? No, you must draw the pictures. So, again, I remind you, before you do the experiment tomorrow, you must send me your design. You know what I mean? Design for this experiment. Now, you just saw me do it, so you should be able to make the picture and explain the steps and all that, okay? So please try to email me that tonight. But if you make some small mistakes in it, don't worry, you can change it before the final report.
Can you draw by comic pen?
Yes, this is what I want. Yeah, draw it by paint or something like this. Yeah. Okay, we'll finish there.
Do we have to create a
Huh? No.
Yeah.
No, I thought I have intake. Yeah. I think I have intake 2 now.
Yeah, intake 2.
Sorry, I need to say intake 1. Don't I? I thought I had you for 2 extra long tomorrow. What's the
So it's 9 to 11 for this prep, and then we have normal physics from 11 to 1.
Are you sure? I need to check this. I don't believe that because I don't believe that because I should have. Yeah. Let me check my timetable, okay? Because I don't believe that. Because then that means I have it for 4 hours. Yeah, and you don't want that. And I don't want that. Well, if I do have you, I'll do the thing I said about the results, the uncertainty calculations. If I do have you, but I don't think I should have you for 4 hours. Because tomorrow I should have you for like 3 hours. Do you have the timetable for tomorrow?
No.
Okay. Right, let me check it for you. What did she say? This room?
Just send us an email saying we have the prep from 9 to 11. Yeah, that's it. And based on our regular timetable.
Okay. Yeah, you have a prep from 9 to 11. But I think you have something else then at 11. Because I know normally you have me at 11.
Yeah.
But I think I will have intake 1 now.
So we have nothing now.
No. I'll find out what you have shortly, okay? Did I...